We have open house with Patel in the house. So, all right, so Pawan Sai, please go ahead and let's get started. Whenever
Thank you.
you speak.
Thank you, sir. Good evening, everyone. Thank you for taking out your time and attending the session. I hope it would be worth learning something. I'll share the screen. Please let me know if it is visible.
Yes, sir, it is visible.
Uh, okay. Thank you, sir. I'll just like take a brief theoretical, presentation.
My
First,
lord, I didn't think you would have slides. You have slides too. Wow,
just a basic few slides made in few minutes.
wow.
I like first of all, I would like to ask the question: what do you understand by data modeling? Okay, so for my understanding, when I heard this data modeling, I thought they would be make some they would be making some fancy kind of stuff, and they'll they'll make it possible or able to they'll make the data structured enough to visualize. That is what I had the brief understanding. In the very beginning, even I don't know that. Later, as I gradually explored that, I was able to figure out only that point. Okay, now what I understood is there are more points for it to explore. Here I have just kept one point. It is one of the features used to connect multiple data sources in BA tool using a relationship. Very simple, right? If there are multiple sources, just we okay, some question.
Uh, uh,
Yes, Amit.
yes, Amit, you are absolutely right.
So data modeling is connecting multiple sources and relating the multiple sources in a BA tool in order to make it feasible to visualize or move to the further step or analysis or anything further. Okay, for this we need some basic concept which is called primary keys and foreign keys. Okay, primary keys are the unique keys where there are no nulls or no blanks are allowed. There is no repetition of values, and everyone I believe they understand what is primary keys. They are the most important keys. The most primary name itself represents that. Without this key, we can't identify the respective data which is present. So this is a student table where I have the first name, last name. This student ID acts as the primary key, and for the course table, course ID acts as the primary key. Now there is something called foreign key. What we understand by foreign is something that comes from outside. Okay, this is my student table, and there is one more ID apart from primary key ID. Okay, this is something foreign which is coming from another table. You could understand by that name, foreign key. But in foreign key, they many people might have enrolled into multiple courses, so the key might repeat. Okay, so it don't worry about the uniqueness of the IDs which are present in the foreign key. Okay, this
At least
for
something I'm understanding. Otherwise, I thought there's one local key and the foreign key comes from US or Japan or China.
yeah,
Or foreign.
yes, this foreign key came from the US. That US name is called course table. Okay,
Okay, okay, I see. I got it. I got it.
okay, that now what we call is just try to understand. Student ID is primary key for student table. Course ID is primary key for course table, and this course ID is foreign key for student table.
Hmm.
Okay, as simple as that. If you are able to understand this relationship between these two tables, we are good to proceed ahead.
Yes, sir.
Okay, yes, sir.
Yeah, we're good.
Yes, sir. Moving ahead, we have something called cardinality. Don't worry about this terminology. It is very simple. I would like to give few examples for these relationships, which is one to one, one to many, many to one, and many to many. Suppose that every person they have one passport. Okay, so every country has one capital, or every person has one brain, right? One heart. So this kind of relationships where one entity is dealt with one particular entity, such relationship is called one-to-one relationship. Okay, that the data might be present in different tables, but wherever you encounter one entity relating to the other entity which is truly related for a single value attribute, you could say it is one-to-one relationship. One to many, suppose that one person can make multiple transactions, right? One person can visit multiple places or anything. So such relationships, it is like one to many. If you look from other way around, it would be many to one. Okay, so they both are like I would say same, but the way they look at it, it depends on that. Okay, many to many relationship is sometimes little typical, but try to understand. Suppose that there are multiple hospitals where they hire multiple doctors to treat, and the multiple doctors, they try to work in multiple hospitals. There is no mandatory thing for a doctor to work in only one particular hospital. So this kind of typical relationships, they are like many to many relationships. Okay, so these are the three types of relationships where we talk about the cardinality. Okay, and moving ahead, uh, we have something called schemas. Okay, so I told you that about the relationships. Suppose that I'm a person who is making multiple transactions. Okay, so I have the transactions data. This is the transaction table, fact table, which we call. And suppose I'm a user. My name is listed in this users table. Okay, now here you could see there is something called one at every dimension table. One represents that every one entity or attribute of this merchant or any other dimension table, it is related to, you could see star here. Okay, this star represents that there are many values for one value which is present in the dimension table. Now let us understand what is fact and dimension. To introduce, fact is nothing but where we have some quantitative data or numerical data, or the data which provides some valid output for the particular context, or you could say person or event, or any particular category, dimension, or anything. Okay, suppose I'm a person, so it is a dimension. Okay, I'm making multiple transactions, I'm purchasing something, making some sales, generating revenue, everything, it is into transactions. So this is the dimension table where we discuss about events, categories, or as I told, the multiple dimensions. And this is a transaction table where we have one to many relationship. Okay, and like, is it clear till now? What is like, why is it one to many, and why is it one to one, or or about the cardinality? Can anyone confirm, please?
It's
Yeah,
clear
it's
for
clear.
me.
So let me, yeah, I think people are getting it. I, as a world's freshest fresher, let me take another example. So, one question comes to the mind is, why do we talk about the relationships? Why do we talk about
Yeah,
modeling?
yeah, yes,
So,
yes, sir.
uh,
That thing, that
no,
is the.
no, Pankaj was saying, suppose we have a sales table, a sales data set which has two tables. The first table contains the sales transaction information. Let the second table contain the customer information. So one has sales information, one has customer information, and both tables have a common field called as customer ID that is creating a relationship between them. Now we can have a proper data modeling or improper data modeling. With proper data modeling, we may, sorry, without proper data modeling, we may end up creating independent visualizations for each table.
Yes, yes, sir.
That is without proper data modeling. But
Yes,
uh, if we create, so if we do it without proper data modeling, it will make it impossible to analyze customer information and sales trends in a single report. However, if we created these relationships that you just talked about, this will help us. If we, for example, if we create a relationship between the two tables using the customer ID field, I can aggregate the data. I can create interactive visuals that will allow the end users to filter data based upon the customer details or the sales trend. So that is why Pawan Sai just pointed out about relationships. So, and he explained the schemas. So those are the two concepts that a beginner must know about.
Yes,
Right.
yes, sir.
Pawan.
Sure, sure, sir. Thank you, sir. In this schema, this is named as star schema. The reason is one fact table, it is related to multiple dimensions. As you could see, it is in the form of a star. Okay. So this star shape, it represents the schema of it, which is present where multiple sources are connected. That is why it is named as star schema. Moving ahead, there is something called snowflake schema, where our fact table are connected with dimensions. Okay, and these dimensions are connected with sub dimensions. Suppose that I run a supermarket. I sold multiple products. Those products are my dimensions. The sales and quantity and other discounts and other data which is collected and made by the customers, it is collected in the fact table. And suppose that the products are my dimensions, and there is something called sub product categories, or there might be some different flavors of a product. There might be different uh, different I could say utility of the products. Like if we buy chocolates, there might be same company distributing other flavors. So those different subcategories come into sub dimensions. So I'll write product subcategories. Okay. So this comes under sub dimensions. If it is like related, then this sub dimensions would be one. Here in the dimensions it would be many, and the dimensions here it would be one, and in the facts it would be many. So I hope it is clear, right? This snowflake schema, it is called as snowflake because the structure, it appears in a snowflake format. One thing is related to the other, and other thing related to the third entity. This thing, it might get connected to some other table also. That can also be the case. Even still, we call it as snowflake schema. Okay. So this is about snowflake schema. Moving ahead, we have something called galaxy or fact constellation schema. Galaxy schema or fact constellation schema, it is named based on the fact tables which are present in the schema. We have two fact tables where there are connected by the joining dimension tables. These are called as conformed dimensions. There are multiple dimensions based on the criteria that they fulfill. You could do little research, and you could understand there is a it is it has vast importance to understand the dimensions, various types of dimensions and various types of fact tables. If you get enough time, please try exploring about data warehouse concepts. They'll be a very good add-on to your data modeling skills. And here, with respect to fact constellation schema, you could notice that this is something where I have seen about the star schema. Okay. And this is again where I could understand about the star schema. So you could say the combination of star schema is helpful to form a galaxy or constellation schema. So do not worry about schemas. Gradually, if when you explore data sets, you'll be able to understand how schemas will help you get the relevant output required. Okay. Moving ahead, we'll discuss about something called normalization, which Arun sir has mentioned, and the importance of all the data modeling skill lies in this normalization. The simple way to understand normalization is nothing but, if at all you have a large database table with multiple facts and dimensions hidden in it, our work is to break down the facts and dimensions into multiple tables. Okay, this is the simple thing. Break one big table into multiple chunks with respect to the dimensions and facts, so that you can better make a model and make it you can analyze things. there is a importance why we do normalize. I'll get back to the Power BI desktop. Let us discuss directly with the Power BI desktop. Mm,
Pawan
Uh,
sir, can I add something here?
yes, sir. Definitely, sir.
I was, I'm like a tube light. I understand things after 5 minutes or 10 minutes, sometimes 1 day or 2 days after they've been said. But today, because you explained it so nicely, I understood understood it fast as the words freshest fresher. So I thought to myself, why we learn schemas at all? We talk about all these star galaxies and I don't know what all names are there for these wonderful schemas. And I thought to myself, and the answer occurred to me. So whenever we learn about, and can you display can you go back a couple slides?
Sure, sir.
So learning about the schemas, I'm trying to understand, you can correct me, that it helps us to understand how to structure and organize data within a database. So a database schema is nothing but a blueprint for how the data is stored and managed in a database. So if we understand these different schemas, they might be able to help us improve the data performance, its security and its scalability. So if we again if we if I had to if I was sitting in an exam, somebody asked me, or if I was in an interview, somebody asked me, why are you learning about schemas? Well, I'm learning it for few reasons. For example, I'm learning it for customization of database design. So I can I if I want to choose the best design that meets my business requirements. I'm looking at improved performance. So if my database is properly designed, it can improve the performance of database operations and queries. It will reduce the time it takes to retrieve data, right? So that's why I'm learning about schema. Also, the third reason could be I'm learning it because these schemas, if you look at it, there are different types of schemas: star and galaxy and snowflake, and there'll be a cornflake schema soon someday. But they enforce the business rules. They prevent the entry of invalid data into the database. So what happens if you prevent the entry of invalid data into the database? You'll have better data integrity, right? Then you'll also have an enhanced security because these database schemas, if a security guy is looking at it, data DBA is looking at it, database schema can be assigned, can be used to assign specific privileges. It can restrict some users. There'll be some unauthorized users who you don't want to give the access to sensitive data. That's where again a schema helps you, and it helps in all kind of end user flexibility, right? So there are many reasons. If we learn the different schema types, we don't have to master them. We have to just understand that these schemas exist so that I as a world's freshest fresher can design an efficient and robust database structure that can meet the needs of an application or a business. So this is what Pawan Sai has taught me, and this is what I remember.
Great, sir.
Back.
Even you have explained in a more structured way. I really thanks, sir.
Uh,
Here we have.
Pawan Sai,
Uh,
sorry to interrupt. Can I add up one
yes,
more
please.
point
Yes, please. Yes,
where it will
please.
help? Means like based on my
Sure.
experience, if you do data modeling, when we use report level filter in Power BI, so like if you have one page, like home page we have created, then other 4 5 reports will be there in Power BI. So in home page we'll create slicers, right?
Yes,
So
yes.
there, if we apply slicer there, it will uh, apply for all the reports. So in that situation, data modeling will help us.
Okay. Do you mean to tell that if it always sync slices for all the
Yeah,
pages
correct,
at
correct. Yeah,
report level, then our data will help database model will help us to fetch the relevant data.
yeah,
Is
because
is
uh,
it is it your interpretation?
correct, correct. A few people will get error where mm, they might ask for other
Uh,
person help
uh,
there.
yes, yes. To add on to your point, I'll tell you if at all a proper data model is not created, whether it is slicers or a visuals or whether it is measures, calculated columns, whatever you make, if you want a relevant output, until unless it deals with a specific table, it is fine. If it is trying to get the relationship or get the input from the other table, if it does not have relationship, then it will give the wrong results.
Correct.
As simple as that. And
Yeah.
until unless we have specific relationships, we can't fetch the data from the other table. That
Correct.
yes. Thank you for adding.
Bro. Okay, thank you.
Okay.
Pawan,
Yes, sir.
Pawan, I have a doubt. So I have a in Power BI. I'm also working in Power BI. I have a table, a common table with number of dates and volume incidents. So can you also after this can you explain me how to create a common date table and relate it up with that
If,
table that I have?
if at all such a table exists, even that becomes a fact table. To be honest, even if you have simple dates along with some volume or other quantity, there might be
Okay.
dates which is repeated, right?
Yep.
So that repetition, it will cause, you can understand simply that in order to create a date table, you need to have unique continuous dates, right?
Yep.
So that unique continuous dates, it will, create one side relationship, and the table which you have, it will be created in the many side relationship.
Yep.
Okay, in order to slice and dice the data or use the time intelligence functions, you might require to create another the date table which is using calendar or calendar auto functions, or you can use
Okay.
DAX script, or you can use M script which is available like
Okay.
in the open source. There is
Sure.
nothing complicated, and of course feel free to reach out to me. But
Sure. Sure. Sure.
this
Sure.
this
Bro.
is the only way which we like how we do it.
Sure.
Uh,
Yeah. Got it.
yes. Moving ahead, I have just saved the empty Power BI file. You see, I don't have any data. I'll just click on this transform data. I'll go to Power Query. Okay. And I'll just click on new source, bring an Excel file where I have a single large table, and I'll try to show you how to break into chunks. Okay. So I have this something called table data, which is saved, named as store sales. I'll open that. Meanwhile, I would like to, since I have explained about fact and dimensions, tables, I would request you to, see the preview of data or else the table which appears. And I would like to know what are the different dimensions that you notice. Okay, let the data be loaded. Okay, here we have a big table. Okay, uh, considerable number of columns. Considerable number of columns. Here we have around 20 columns. If you could see in the left bottom. Okay, here we have multiple columns, around 20 columns. Now I would like to ask about the columns. This order date, shipping date, invoice dates. Is it dimensions or facts? Can anyone answer?
Dimensions.
Dimensions. May I know why? Hello.
Fact will have numerical data, but this is date, so it has to be dimensions. Is my thinking.
Okay. The thing is actually, you could.
These dates should be part of our fact table only, so that like we can check verify on which date order was placed, shipped, or invoice date.
Yes. Of
Fact
course,
table this one.
yes. It has to be in fact only. We can't conclude directly, but they are supportive
Table.
columns, which are part of fact table. We can call it dimensions if at all we are if at all we are having that in like we are trying to analyze in a unique number of rows. Okay, suppose that moving ahead, I'll discuss about what I mean about unique rows. Let us move ahead apart from these columns, considering that they must be the part of fact table. we'll discuss about the utility of these dates while I talk about role playing dimensions. Okay, now is my customer key and customer columns, are they dimensions or facts? Can anyone tell me?
Fact.
Okay,
What are dimension?
yes, it is dimensions.
Dimensions.
So,
Dimensions
like
which
in
are
fact table, they like customer key basically can work as a foreign key in our main table, like in fact table.
yes.
Wait a second, Pavan. Customer table is a fact table, no? It can't
So
change.
this sales table which I am showcasing, it has both facts plus dimensions. What is our task in the normalization process is we need to separate facts and dimensions and create relationships between them. Why we are creating, I'll explain you the major impact of it. So here this customer key is a foreign key, as someone said about. Here you could see that similar to the course id, this customer and customer key is the different table where we have to separate it out from the fact table. Okay, here we don't have this dimension table separately, we have only the first fact table. Okay, we have to separate the dimension table. That process is called normalization, where I have told you. Right now this process I am trying to tell you, or demonstrate, where we separate the single table to multiple tables. Okay, the reason why we are separating, it has many usages. First thing I'll tell you, for data integrity. Okay, data integrity, you could try to understand in this way, where the data is not, it is relevant to the data which is related to the relevant rows are not missed out without any you know without any particular entity. Okay, to make sure that the data is properly structured and related to the respective information which is connected, to maintain the data integrity, we do normalize. Second thing is data redundancy. Data redundancy, can anyone tell me what is what is meant by redundancy? Data redundancy is nothing but something which has more repetitions. Okay, here if I change the column profiling for the entire data set, if I click on this column of customer, you can notice how many unique customers are there. Okay, in the column distribution, you could see that there are 6,954 distinct values, distinct customers. If at all I go to transform, click on count rows, here you could see there are around 14,000 rows. So you could understand that the 6,900 customers, many customers are repeated twice or thrice, whatever it may be. You could understand that the data is repeated, right? So this repetition, when it is made for few thousands, it is okay. What if the repetition is made for a few millions of rows, and what if there are hundreds of columns? It would occupy a lot of space in the fact table, right? Would it perform well if it has large data which is repeated? No,
No,
right?
it will be inefficient and inaccurate.
Yes, that is something called as data redundancy, where we have repeating unwanted data and we have to reduce that. This foreign key will help us to fetch the customer names, and then we can remove the customer from the fact table since it is a dimension. I'll show you how to remove it and how to make the relationship. For now, we are noting down the points in order to understand. This data integrity, data redundancy are the two major reasons. There are multiple reasons, like performance reason could be there, and regular updating of data, to make it easy and connected, we need to make this normalization. There might be client requirements where dimensions are more changing, or there might be slow changing dimensions. You could explore about multiple reasons and benefits of normalization. These are the few important points which you have to always keep in mind. Okay, now discussing about this fact table, can anyone tell me what is the customer information related to? Is it dimension or fact?
It will be dimension.
Dimension. I
E-
think
e-
dimension.
yes. Okay, now I have foreign key as customer key and customer is my dimension.
So,
Okay, store.
so Pawan say the way I'm trying to, as the words fresher, the way I think about it is, whenever we think about dimension table, it contains attributes or some characteristics, right, of the business. For example, time, customer, product, or location. Each dimension table usually will have a primary key that will identify a unique record, right? A
Yes,
fact
yes.
table. So a fact table, if I correctly remember from what you have taught me, is it contains measurable and numerical data that is being analyzed. For example, sales, revenue, or quantity. So the fact table will have the foreign key, which will be linking to the dimension tables. So that's how we differentiate between fact table and dimensions. So the question you're asking, people will be easily able to understand if they are very clear about what is a fact table, what is a dimension table, how do they differ. The other thing you talked about here is the data redundancy, and you very rightly explained that data redundancy is a situation. It occurs in a database. Wait a minute, let me admit somebody. Okay. So same piece of data, what the example you gave was, we saw that the same pieces of data was stored in multiple places. And it can happen when the data is copied or pasted from one location to another, or when the database is very poorly designed. So data redundancy is undesirable, as you rightly pointed out. Wasted storage space. It takes a more storage space. And what does that mean to us? What does that mean to customer? If it takes more storage space, it will be costing more money, because I'll be asking for more and more storage, and customer will be unhappy. Similarly, the redundant data can easily become out of sync. It will have inaccuracies and inconsistencies. It will cause problems when trying to use the data for analysis. And the whole job of a data analyst is to analyze things, right? So then it will have inefficiency, because it will require more time and effort. If I maintain 10 different copies or 20 different copies of the data, it will be inefficient. So for all those reasons that you just pointed out, we understood the concept of redundancy as well as the dimension fact table question that you asked about. With that, back to you.
Thank you so much, sir. You have made a good conclusion. Here as data redundancy, you could see that there are around 150 stores, but the data is repeated in 14,000 rows. So by this you could understand the store name is repeated a lot, and it is occupying unnecessary space, memory, and everything. So it will hamper the performance and processing speed. Now let us understand, is a store information which is stored, is it dimension or fact?
Dimension.
Good. It is a dimension. Moving ahead, we have something called region key and region. Is it a dimension or fact? It is dimension. Okay. Can anyone answer me these few questions? After that, most of the things would be clear. Okay. Now I have something called city or town. Okay, I don't have any key for it. Region key, I have the region. Okay, you could see that there are 16 distinct region keys, 16 distinct regions. Here for cities and town, I don't have any key. Can anyone tell me what would I do in this case?
Can
I
you
will look at
go
Akshay
to
Gupta.
Hello. So I hope everyone is working on some or other SQL or Excel or Power BI, right? I am requesting you to just tell me what is this city and town?
Should that
You
come
know,
in
where
hierarchy?
I don't have any relation. Okay, like could you please elaborate what does it mean by hierarchy?
Uh, Going up in level is hierarchy. Going up or going down. So like it should follow like country followed by state followed by district followed by city.
Yes, yes. You are correct partially, but that thing will we have a terminology something called as granularity. Okay.
Yeah.
Suppose in that hierarchy, as we go to the like most granular level, here one city can consist of multiple towns. Okay, see here there are 45 distinct cities. Towns you could see 149 distinct towns. So the most granular part within these two columns, it is town. You have rightly said it is it is based on the hierarchy, but since we don't have any key for it, we could consider that most granular part which we have as a key, foreign key. If at all I make it a primary key, all the cities would be included, right? If at all I make city distinct, by removing duplicates, there many towns will be missing out. So you have to understand with respect to hierarchy, you have to understand the term granularity. Sand, right? We have many particles. If there are multiple multiple entities or multiple values, that we can understand it is more granular to make you understand as a in a very layman terms. So here we consider this town table. Our town is a key, okay, where I have this town and city columns. Okay, one more thing. I have something related to sales agent, key and sales agent picture and all those details. Is it my dimension or fact?
It will be dimension only.
Yes, good, good. One last question. Okay, we have this product key, product and product category. Would it be my dimension or fact?
Again,
Dimension.
dimension only.
Again, dimension. So you can see that one in one fact table there I could identify 6 dimensions where I have the multiple repetitive data, very large data, which is unnecessary floating and causing it will cause impact if it is if it has millions of rows. And moving further, this last easy question: unit price, unit cost, and quantity, are they dimensions or facts?
Fact.
Facts.
Facts.
These are facts.
So we have got a simple picture where I have 6 types of dimensions, right? So I have got this picture. Now I need to separate these dimensions from the fact table. In Power Query Editor, what we do is we'll right click, let us duplicate the table. Okay. Now what we do is, except let us suppose I'll rename this table as dim customer, just to understand that it is a dimension and it is the customer related table. Instead of sales, I'll write fact sales. Okay. Now in the dim customer, I want only customer key and customer unique values. I'll right click and remove other columns. Okay. So what it does is it will remove all the other columns except these 2 columns. Okay. Now here we have removed all the other columns, but still there are around 14,000 rows. But I know that there are only 6,950 some customers present. If I could change the column profiling in the bottom, and you will see the right picture. Okay, make sure that you change this column profiling if at all you are watching the distribution. Okay, now you could see that there are 6,954. If you go to transform and click on count rows, you'll see a wrong number. So by this, I understand that I want unique customers. I'll click on this customer key. I'll go to remove rows, remove duplicates. Okay. Now you have the dimension table with you. I have unique key, customer key, which is my primary key for customer table. And here in the fact sales table, I have this foreign key and the respective customer. Let us understand why I'm doing this at the end. But try to understand here that I have separated one dimension. Let us quickly separate other dimensions also. I'll duplicate the fact sales. Another dimension which I have, it is something called as store. Okay, to name it in a easy way, I'll write dim store. Okay, if I scroll to the right, we have something called as store key and store name. I'll select these two columns. I'll right click and remove other columns. Now I have this store key and store name. There are 14 distinct values, but if I change the column profiling, here you could see multiple values which are around 150. I'll select the store key, remove duplicates. Now we have removed the duplicates. This is our dimension store. Okay. And if at all you like to see the difference, in the bottom you could see that there are now only 150 rows instead of 14,000 rows. I'll go to the fact sales data table. I'll right click, duplicate. Here I'll now make the another dimension called dim region. I'll hit enter. Wait for another 5 minutes. You'll understand why I'm doing this. I'll just select the region columns. I'll remove other columns. I'll select the region key. You see this one distinct, but don't get cheated by it. Click on that column. Click on remove duplicates. You see the magic. We have 16 distinct values. Okay. Similarly, let us go to the fact sales table, duplicate it. Okay, now moving ahead, we have something called city and region. Select these two columns, right click, remove other columns. Okay, now try to understand this town is my primary key for this dimension table. So I'll select the town, I'll remove duplicates. Now once I remove the duplicates, you'll see that this Salamanca, it has multiple towns. This Avila, it has multiple towns. So similarly, town is the primary key for like for this table, dimension table, which I'll write the name as dim town. Okay, moving ahead, I'll select the fact sales. I'll duplicate it. I have something called as sales agent. I'll write dim sales agent. Okay, if I scroll to the right, we have dealt till town. Here I have something called sales agent. I have these three columns. I'll right click and remove other columns. Now you could see that I'll select the column profiling. You could understand why I'm doing this again. I'm repeating the same point. Here there are 9 distinct values, but if you check rows, there are 14,000 rows. These 9 sales agents, their names are being repeated, their picture codes are, repeated, keys are repeated. I'll just, remove duplicates. You could understand you could understand that this 9 people, that their data is populated in 14,000 rows. Imagine if what if there are million rows. So that is why we are making dimensions to keep them separated. And what if in the dimensions there are multiple columns? Okay, those unnecessary data will be repeating. Now finally we have something called as product related information. I'll just duplicate. I'll just scroll to the right, and we have something called as product key, product category, and product. These three columns, I'll select it. I'll remove other columns. Okay, again the same, select the product key, remove duplicates. I'll rename the table as dim product. I'll hit enter. Okay, now we have made this 6 dimension tables and we have one fact table. Let us go back to the fact table. I have 20 columns now. Okay, now let us remove the unnecessary columns. In the dim customer, I have customer key and customer. Do I require this customer column? Can anyone tell us?
No, not
No, right?
required. No.
I can fetch the table from dimension table, right?
Right.
Simple. Moving ahead, do I need this store column, store name column,
Not required. No.
region column,
No.
city column?
No.
Okay. What about sales agent?
Not needed.
Do I require town?
Yes. Sounds required.
Yes, it acts as foreign key. Do I require agent picture column?
No.
Moving ahead, do I need product?
No.
Do I need
No.
product category?
No. No.
No. So all these columns, they are unnecessarily occupying the space if at all I have specific dimensions. So what I can do, I can select the columns, just remove columns. Now you see our data is reduced to 12 columns. Would it be efficient enough? Right? We have all the relevant information. We have all the foreign keys, okay, which is present and which could help us with the relevant information, right? And we have all the respective dimension tables, right? Is this fact table, more efficient, or the fact table which consists of 20 columns more efficient?
This one is more sufficient.
So
This
this is more efficient because we have reduced that data redundancy thing. Okay, I'll just close and apply. Now we'll see something about relationships, the thing which I'm talking about, schema.
Hi, Pawan. This is Navish.
Yes, please.
I have one question. When data got refreshed and more data got added, it's in a duplicate table or dimension table is automatically get added the datas.
Yes, it will be added, but if at all, what happens is, many times, once you get into the industry, remember this: 90% of your projects will be dealt in direct query. Okay, and there will be large database tables, and whatever you do, you'll be dealing it with direct query, and the dimensions which you deal with, they are limited data where you could import many times, until unless in exceptional cases, dimension tables are more static enough. They're not much dynamical, so what happens is, fact table, they'll be brought from direct query, which is from the database directly, and these dimensions, they are imported. Okay, so normalization, it is done only in specific cases where you want to split into the different tables. Otherwise, it'll be dealing with the direct query, which refreshes the data automatically. Need not worry about that.
Okay, got it.
Pawan, sir,
Sometimes
before you start the next series of thoughts, I would like to acknowledge some members who just joined us, like Aparna and other people.
Sure,
I'm
sir. Sure, sir.
I'm happy that they were able to finish their evening snack, and even though the class started at 5 o'clock, they joined us right 5 minutes before 6 o'clock. So I hope next time they will have their snacks early on, so that they can join on time. Thank you, Paul.
Thank you, sir. Here we have loaded the data. Here in the right side, you could see the data tab where the multiple tables are loaded. I'll move on to the model view where we could see the multiple tables and the relationships being created. Okay, now this is the star schema which is created by default due to our modeling. Otherwise, we had only this fact sales table, and all these dimension tables, you could see that they formed a star schema. Okay, very simple to state. Now here there are two things which you have to keep in mind. These relationships, They are created based on the column name. Okay, here I have product name, product key column. If I double click on this relationship, you could understand that fact sales, it has multiple keys of product, so it has many relationship. You could see this star. In dimension, you have only unique dimensions in dim product table, so it is creating one in the dimension side. So here if I click on that, one to many or many to one relationship cardinality, it is same, and the relationship is active. Let us do one thing and let us understand how to manage relationships. Okay, here I have multiple relationships. I'll select all the relationships. Okay, and I'll just select delete. You can ask me, Pawan, why are you deleting and why my relationships will be gone? So the reason is you need to identify the relationships and quickly make relationships. Okay, before showing how to make relationships, you need to understand a default setting which system does at the back end, where you need to disable it if you want to learn good data modeling. Okay, if you click on options and settings, click on options, there will be a prompt. There will be this pop-up window. Click on data load. There is something called auto detect new relationships after the data is loaded. If you uncheck this and click OK, it will not detect the relationships of the tables. It will just throw you the tables. It will tell you do it. I don't know. Okay, just click on this. I just kept it default. I'll cancel this. Now let us go to manage relationships. If you click on auto detect, it will again auto detect everything. Okay, I'll just click on it. You see how it quickly auto detects. I'll just click close. You see how quickly it auto detects. But I don't want this to do. I'll just click on delete again. I'll remove that. Now I'll create my own relationship. Many times don't trust the data tables, because in the schemas which you will be dealing, the names might be similar but the data would be different, right? So you have to have the strong understanding of data before you make the certain relationships. Now I'll select the facts table, and here I'll select the customer. It has identified this customer. Okay, it has many to one relationship. I'll just click OK. Now my customer relationship is made. Similarly, I could make multiple relationships with the fact sales table. I'll select the product key is selected, and then many to one relationship is there with the relationship active. I'll click OK. So I'll just quickly make the relationships. Fact sales, region key is selected, and the cardinality is fine. Just click OK. Fact sales agent key is our foreign key and primary key. Click OK. And here we have something where we have this store key is present. Click OK. And this final thing which we have is dim town is selected by default. So you should make sure that the relationships are appropriate. Now our relationships are fine. We have verified it, we have created it. I'm closing it. Now you can see that relationships are coming back. So these relationships, it will help you to slice and dice the data accordingly. You have multiple multiple dimensions where multiple details are present. You can just go to the canvas. You can play with that. Suppose I'll bring the customer name, okay, into the table. So this is my customer table. So in the data, again, I'll go to fact sales table. Suppose that I want to sum the quantity. I'll just click on the quantity. Okay, I'll just select the table in order to make sure that it is visible in a table. Okay, here you could see that the respective quantity is sliced down, and it is filtered down, and it is showing us the correct results. I'll increase its size, okay, so that it is visible enough. here we have this customer and quantity related information where we understood that this even after separating the dimensions from the fact table, single fact table, we are able to slice the data and get the necessary output. And this relationship, it is helping us to filter down the facts which are related to it. So that is the main thing which you have which you have to understand about the relationships. Now I'll try to explain you a few things about the role playing dimensions, where it might be some commonly asked interview question. Okay, here you have something called order date, shipping date, and invoice date. Okay, if at all I want to find the total quantity based upon order date, it is fine, because you could see that. Okay, here, okay, what I have is order date. Is order date related to something? No. Okay, let me show you quickly how my dates comes into picture and how it impacts the necessary output which we want. I'll open the fact sales. Now I'll open this visualization, select a table. Here I have a simple table. I'll select the columns of invoice date. I'll select the invoice date. Okay. What I'll do is I'll right click. I'll click on invoice date. Okay. For this particular date, now suppose that I want to view the quantity. I'll just select the quantity. Okay. Now here we have the quantity. I'll just increase its size a little. Okay, now that invoice date, particular dates, it has the respective quantity. I'll just copy and paste the table. In this second table, instead of invoice date, what I want is something called ship date. Okay, the day in which the okay, here I have this shipping date. So I have these two different information. Okay, we have to create this shipping date into the shipping date. Okay, now for this, January 2021 Friday, this based on the invoice date, the quantity is 60, but based on the shipping, it is 202. Okay, now I want to understand these two different things in order to filter based on a particular dimension. That is the reason why we create something called dim date table, where we create something called dimension date table. Okay, you know that how to create dimension table related to the date. I'll just click on new table. Okay, here what I'll do is I'll write dim date equal to, I'll just use this calendar auto function. I'll close the parenthesis and hit enter. Now it has detected that, okay, my data is present from 2021. If I sort it in descending order, it will show me that the data is present till 2021 December 31st. Okay, I'll keep it in ascending order. I'll change the data type to date. So since the time factor is not important to us, so we can make multiple columns like year and all those. Here, to our advantage, we have something called date hierarchy. I hope you understand what hierarchy is. Okay, now what we are going to do is we'll understand the relationship when we create with the dim date table. We have got this dim date table, our new table. Okay, our new friend for the data modeling. Here I'll select this date table with the order date. So if at all you are not able to view this, just don't worry, go to manage relationships, just click on new. Okay, now I want fact sales. I'm clicking on this order date. I want to select dim date table. I'll select this column, many to one relationship is formed. I'll just click OK. Okay, I'll close this. Our relationship is formed. It will take a minute. You see this, our relationship one to many is formed. Now, instead of taking this date separately, what if I select the dim date table? Okay, I'll just reduce it a little so that I could show you what happens if I slice the data based on the dim date table. I'll copy this table and paste it. Okay, here I have something called new table where I'll change the shipping date to our new friend, which is dim date column. I'll change it to date. Okay, now you see this, it is totally showing me a different thing, which is 766, because now this relationship which I have made, it is based on the order date. Okay, this one it is based on the invoice date, this one it is based on the shipping date, now this one is based on the invoice date. Now I am in a confusion. How should I get the necessary output using the date dimension? Okay, to avoid confusion, what I'll do is, for now I'll tell with respect to the two things. What I'll do is I'll remove this invoice date from the picture. I'll just keep this table, this left table. Now you understand that my relationship with the table is with the order date, and this second table, it is directly fetched from the shipping, the shipping date within the fact table, right? Is it clear so far till now? Anyone?
Yes. It is clear.
Yes. Thank you, sir. So here we have one single relationship with the order date based on which our dimension table is, trying to filter out the quantity. Okay, now here I want the shipping quantity also, but it is not able to do it because I have only the relationship which is active for the order date. Okay, that is where our DAX helps in order to make this shipping date relationship possible. Okay, I'll show you how, but to make it possible, what we need to do is we need to create another relationship which is an inactive relationship. First thing which you have to understand is the fact table and dimension table, anytime it will have only one active relationship. If at all you create another relationship, it will be inactive. I'll show you how. I'll select fact sales, I'll select dim date again. Instead of order date, I'll select shipping date. Now this many to one relationship is formed. If I select it, it will throw me an error. You can't create direct active relationship. First, make the active relationship inactive and then do it. So I have to uncheck this. I'll just click OK. I'll close it. So if at all I zoom in, okay, you have something called this solid line, which represents that active relationship with this solid line. It has the active relationship with the order date. Here you could see order date. This dotted line, it has active relationship with the shipping date. So this dotted line, it is inactive for the shipping. This solid line, it is active with the order date. Very clear, right? So it is just filtering down with respect to the order quantity. Now I want to make it possible to sum the quantity based on the shipping date. What I'll do is I'll create new measure within the fact table, or you can create even another new measure table if required. Okay, now what I'll write is shipped quantity equal to, I'll write calculate. Okay, my intelligence is not working. Now it is working. I'll write calculate. So the first parameter of calculate, it would be aggregation function where you use the expression, right? So here I would like to sum the quantity, fact sales quantity. Okay, I'll put a comma. In the filter argument, you need to provide a filter argument where it could modify the filters. Now here I have this filter modification, here in order to make the relationship, we have something called use relationship. This helps us to create new relationship. Okay, now where we have to create the relationship for the dim date, I'll put a comma with which column we want, with the column where it is fact sales shipping date, because we have already created the relationship with order date, which is active. The shipping date relationship is inactive. That should be created for in order to make this measure work. So I'll just commit. Okay, this basic simple measure with the aggregation in expression and use relationship function in the filter argument. You have to write that. Now our shipped quantity is appearing. Okay, now if I select it, and if I could bring it, add the data, and if you could add the measure, which is shipped quantity, okay, you could see that this sum of quantity is with respect to the orders. I could rename as order quantity, and this shipped quantity is calculated based on the measure which we have written, where we have created something called as use relationship function. Now this role playing dimension, you could understand that this dimension table which we have created, the date table, it is called as role playing dimension because it is playing, two roles with the same fact table as a relationship. Okay, did you understand this measure which I have written, and why we are doing this? Anyone, please?
Yes.
Yes, thank you, Ankita. So one last thing I would like to show you briefly for now, and we shall, I shall hand it over to Arun. Here, many times you might get some, difficulty with the many to many relationship. You could refer this Microsoft, web page where you have how to apply many to many relationships. Okay, if at all you have this many to many kind of relationship, you'll get this warning thrown. Okay, why? Because it can't be solved directly, where there will be a conflict. So there could be a possibility where you make bridge tables making unique columns, but it could result in only partial output. Here you could see that, like, try to go through this, just search for many to many relationships, try to go through this article where you'll understand to create a bridge table, and where you'll try to bring the necessary output, and you might understand few other nuances.
Or I think I have a better idea.
Yes, sir.
So I think if I contact Power Sai or Power Rashika or Power Chandra, I think I'll get a faster answer than like reading up all these articles. So that's my solution. So having said that, could you kindly provide your LinkedIn ID in the or someone can Prem Sai can provide your LinkedIn ID, which from which people that who do not know you or not connected to you yet, they know where to reach a Power Sai.
Yes, sir, I already sent.
Thank you so much.
Thank
Hey, on a
you.
side note, I was thinking, there are some books available on, which we have distributed before. Not distributed, we have shared the notes for our study purposes only. I'm making myself very clear. There's a book called Mastering Power BI, Data Modeling Techniques, Tips and Tricks for Effective Business Intelligence. It's by a guy called Brett Powell, I think. Then we have Beginning DAX with Power BI by Philip Seamark, SEAMARK. MARK. We have Practical Power Data Modeling for Self-Service by Paula, and I cannot remember her last name for some reason. So those are a few books. I think there's also a book called as Analyzing Data with Power BI and Power Pivot for Excel by Marco Russo. These are some of the books that will, if somebody is more interested in learning about data modeling and other things, and if you know SQL and Excel, these books may be able to help you in addition to what Pawan Sai has talked about. And Pawan Sai, I am hoping that you will continue this wonderful series of education from time to time. And you really surprised me, Ponsai, though, because I think again, I again did the trick with you. I said at 3 o'clock, are you ready to give a new presentation? I said yes. I was like, wow, this guy is like ever ready to give a presentation. So, but thank you for being here, Ponsai. I'm not sure if you're left with any um, if you have any last message for the audience, because
Yes,
we would like to switch over soon to Sachin, who's our next attraction, and I will describe about him in a minute.
yes, yes, sir. My few words and few suggestions would be that I'll get back to my PPT again, just to make sure that whatever you have gone through, gone through it till now, they'll be recapped by these basic points, which are also best practices. Is my screen visible, sir?
Yes, sir.
First thing what you need to understand is understand the client requirements. Okay, without this, even if you have the data in your hand, you'll not be able to modify, or you'll not be able to make the necessary transformations for your data model. So understand the data requirements and then do the right modeling. Normalize the data only when required, not always. If you need to understand, the single table also works fine if it is a small table, and you need to normalize when there are multiple dimensions involved and there is some performance issues or whatever the requirement is. Based on the requirement, if it supports your analysis, then do normalize. Denormalization when necessary. Denormalization is something where we do the reverse process, like as we separated dimensions to fact two dimensions, we can even merge the using merge query in power query. We can even denormalize it and make the fact table bigger. Okay, even that would be sometimes necessary in order to speed up the performance.
Mhm.
Okay, the based on the type of data which is present. And also try to keep it simple as possible. Do not make more complications, because as you move ahead, your past mistakes will accumulate, or it will be a running total or cumulative total for the future mistakes. Okay, and establish relationships. Without relationships, you can't slice and dice the data. So you need to establish relationships. You can't expect the data give you right output without making relationships. Use the indexes wisely. So that is where I have mentioned about the primary keys, foreign keys. Have a strong understanding about the keys and the indexes. Many times, even if you don't have the indexes, you need to understand that you can create indexes by creating new index column. You could, in Power Query, you could go to add column and create new index column, and make a new keys with respect to that. Okay, you can make even custom keys starting from 1 2 3 4 or 1 2 5 6, continuing from with increment of 5 each. You understand, if you understand Power Query, you can create the index columns very easily, but try to understand and use it wisely. Finally, consider performance. Okay, this performance, if at all it is taking more time to open and process the visuals, client will be frustrated. He could tell that I would rather go for Excel, which is faster than this, right? So since your project will be involved with monetary things also, so make sure that the performance and client satisfaction is not impacted. There are a few other best practices with respect to DAX and other things. Please explore. And these are the few minimum basic things which has to be kept in your mind while doing the data modeling. And thank you for the session. Have a nice day.